Welcome. I'm a desperate woman trying to get through what we need to before the vacation. So we're going to do this hypothesis test lesson together. The worksheet is online in today's notes, and I just wanted to tell you take notes as we go along. So here comes this dude Jordan, and he claims he can make 80% of the basket that he attempts. You think he's exaggerating, so you decide to put him to the test. What we have here is a case that's a little different than the past. When we did an interval, we had an estimate of the real value. Now we have what we think the real value is. So our null hypothesis is always a statement, and it usually looks like this. And let me just get some pen here. It's something like h sub 0, that stands for the null, p is equal to 0.80. Now, that p we're going to define underneath. We're going to say, well, gee, when we define the parameter down here, p is the true proportion of baskets Jordan makes. Now, the alternative is always what you're trying to prove, and we designate it as h sub a. Now, we think, according to what the given here was, that we think he's exaggerating. So with that said, we're going to say to ourselves, well, gee, then we think the real value is less than 0.80. With that said, the null I think of as the status quo. It's what's the commonly held belief. The alternative in that case is what we're trying to prove. So there's three parts of it. What we think the true proportion is, the alternative, what we're trying to prove, and then the third part is defining your parameter. What does p equal? Now in this case, and this is where it's really different than an interval, it's like a trial. At the beginning of a trial, somebody says that they're innocent, and we assume that they're telling the truth. Well, in this case, we assume this 0.80 is true. So with that said, we're going to go to the next page, and we're going to check some conditions. Just like before, it's R, T, and ln. Now, just to save time on my little tape here, for the random, it doesn't say whether we're going to have a random sample. I'm actually thinking something. Let's just check Jordan out for a second. So we're going to go over to the site, and here's Jordan already. He's taken 20 of the hits or shots, and he's only managed to get 8 out of 20 in. Let's have Jordan do 30 more. And what's going to happen is we're going to watch and see what happens as Jordan's taking these shots, so that we'll have some evidence, because every trial needs some evidence. So I hate to say this, I think Jordan stinks. If we look at that line on the top, that at 80, that's what we claim it is. And Jordan took 50 shots and he got 17 in. Ouch. So I'm going to make a note up here that our evidence is that he got 17 out of 50. So just like a trial, we're assuming that the person is innocent, or what they claim is true, which is this 0.80, but this will be our evidence to try to prove the alternative, which is that he actually gets less than 0.80. So the random, we're going to just kind of go through these verbally. Don't do this at home, you write them out. It wasn't random, but we hope it was a representative sample. The independent. Jordan's a machine. He's an applet on a computer, folks. So he's not getting tired. The success of each shot is independent. And 50 is definitely less than 10% of all shots he can take. Here's the difference. In the null, we assume that this 0.80 is the real value. So we have to use that. So when we check conditions, it's NP greater than or equal to 10 and NQ greater than or equal to 10. Our N is 50 because he took 50 shots. Our P, we claim that he really got 80% in. that is 40, which is greater than or equal to 10. The next part is the 50 times Q, and that's 10, which is greater than or equal to 10. Proceeding on, we are now going to show the mechanics of the test. Step 1, name the procedure. This is called a one-prop Z I take that back. This is a one-prop Z, and here we go, a one-prop Z test. We're testing if his claim that he's 80% is true, or if what we're trying to prove, which is that he's less than 80%, is true. Okay, with this said, he claims he gets 80% in. And like I said, this is a trial. We assume the null is true, which means here we also assume the null is true for the standard deviation. So we have 0.8 times 0.2 over 50. Now, if I remember correctly, Jordan only got 17 out of 50 in. So with that said, our p hat, which is our only evidence, is 0.34. So what we're saying is, if the true proportion of shots Jordan gets in is really 80%, how likely would he get 34% of his shots in or less? I think you know what's coming now. We're going to set up a z-score. Z is equal to R score minus the mean over the standard deviation. Now here's the beauty. We can get that z-score by hand. No issue. We can do normal CDF like we always do, or we can let the calculator do all the work for us. So if you go to your handy dandy calculator, we're going to go to Menu, then we're going to go to Statistics, then we're going to go to Test, and this is a one proportion z-test. P sub 0 means what did we assume was true in the null, which was 0.8. The number of successes was that Jordan got 17 out of 50. And the alternative, what we're trying to prove, is that he's really less than. We hit OK, and it gives us, wow, a z-score of negative 0.813 and a p-value, that's our probability, of about 0. So going back here, negative 8.13, and we call this probability we got in a test, we call it a p-value, is approximately 0. What we're saying right now is that if Jordan really got 80% of his shots in, the likelihood he did this incredibly bad is just about 0. So, do you think, based on our assumption in the beginning that it's 80%, do you think that if it's really 80% he did this badly? And hopefully you're saying, no, Mrs. O'Brien, I don't think so. So this leads us to the conclusion. Now first I want to define a p-value for you. The p-value is the probability of getting an observed statistic at least, now it could be as low, depending if it's a less than, high, if it's a greater, or extreme in either direction, which you're going to see in the next question, given the null is true. Well, our decision now, and it's very fierce how we do this on the AP exam. Let me move this up in case you need that. They need you to link your p-value to your decision and then interpret in context. So we're going to say, because my p-value is low, And I know what you're thinking, well, what's low? Usually we think of low as anything below 5%. If they give you a different level, which they call a significance level or alpha level, then we use that. But if they don't give us anything, we usually use 5%. So because my p-value is low, which basically means 0, we have evidence to reject the null. This is what I mean by linking the p-value to your decision. But you now need to interpret in context. And what we're going to say is, because I know the null is not true, I have evidence the alternative is true. I have evidence that the true proportion Jordan makes is less than 80%. Now I'm going to juxtapose this with the following statement. If the p-value wasn't low, we wouldn't have evidence to reject the null. We would say, because my p-value is high, I failed to reject the null. And then we say, I don't have evidence that the alternative is true. And the alternative here is that Jordan gets less than, what was that, 80% of his shots. So you're always linking the p-value to the decision, and then you're saying either you have evidence the alternative is true or you don't have evidence the alternative is true. Now, I'm going to tell you a little silly thing, and I know this helped my son, and I'm sorry I have to say this, but the saying in stats is, if the p-value is low, reject the hoe. Sorry, that's really bad, but it helps. And another kind of cutesy thing is, the null is upset because no one accepts him. That's a C. Now I know that's really silly saying, but we never prove the null is true. Think of a trial, okay? In a trial, we never find the person innocent. We always say that they're not guilty because maybe there's some evidence we overlooked. So let's go back to the beginning and just rehash this all. The null is your statement of status quo. We're going to write it symbolically. There's no hat in this because we're saying the true proportion value is 80%, not the sample. The alternative is what we're trying to prove. We will always define what P is. That's our parameter. We're going to check our conditions, but we're going to use P and Q, not P hat, Q hat, because we're assuming the null is true. Just like in a trial, you assume that the null is true or the person's innocent. We're going to name our procedure. We're going to take our test statistic. We're going to calculate our z-score, and then we're going to go to our handy-dandy calculator and let it run the test. And at the end, depending on our p-value, we're going to calculate or make a conclusion on whether or not the null should be rejected or failed to reject. Low null, reject. High null, fail to reject. And we're always going to have a linkage to the p-value in our decision and interpreting our conclusion in context. Hope this helped, guys.